Tyler, this beat go.
My name is Andre Brown.
My name is Samra Terani.
My name is Javante Yallen.
What are Arduinos? Arduinos are microcontroller boards. Microcontroller boards are devices that have peripheral features needed to implement the computer portion of an embedded application. Arduinos was founded back in October 2015. The main purpose of the Arduinos was for students to create something with a microcontroller without actually having to spend hundreds of dollars. For the previous microcontroller that was out before the Arduino, at minimum it costed roughly around $100. It was called the Basic Stamp. The new and improved Arduino microcontroller is roughly between $10 and $25. A college student actually wrote the Arduino program. Later, Tom, one of the key founders of the Arduino, actually took the product to a whole nother level once he actually discovered that this is really good for students in schools, but it could really become so much better if everybody used it instead of actually having to go out and buy different parts to actually put something together. He also felt that the students in his schools shouldn't only use it because that's what was the purpose for. It was for his school and another school. But now it's pretty much everywhere and for everybody. In the beginning, they put together 200 Arduino kits, so the Arduinos wasn't completely together. It was pretty much just a kit. And this first selling price, and it was actually selling it, they really didn't make any money back because they were selling it for the same prices that they bought all of the mini parts for it. So they didn't make any profit at all. When they actually started making money and making a brand for themselves, started making 75 cents off each board. And starting out, they had 200 units. The Arduino team, they contacted SparkFun to help promote and release the Arduino for more exposure. SparkFun turned them down because they didn't like the fact that it was a kit. A little while later, Tom reached back out to SparkFun and he actually told them that this one is more together and it actually has a USB version, so pretty much everything is together. So SparkFun actually gave them the time of day and actually took 20 units to sell. That 20 units ended up turning into 40,000 units over a course of just a little time. Arduino is the first open source hardware mini board, which is also just saying that it's the first board that's open to where you can do almost anything with it. The Arduino company allows anyone to make anything with the Arduino and actually sell it. The only thing they have to do is just show credit. That's all they want, pretty much. With Arduinos, you can make almost anything: a remote control car, a robot, a fan, a 3D printer. The list goes on and on.
There are many ways to create CPUs. I'm going to explain how a CPU is made from the help of global founders. For the most part, a CPU is made of silicon, which is the most common element on Earth. The science behind the Arduino are simple but long steps. In the beginning of making a CPU is the creation of circuit diagrams. Experts and engineers collaborate to design circuit diagrams, integrated circuits like microprocessors, high graphic processors, and wireless communication ICs. After the experts designed it, the following step would be manufactured the microprocessors. Microchips are made from sand and are often called silicon wafers. We will need wafers for the development of the Arduino. Wafers are manufactured in a clean room that are 100,000 times more cleaner than an operating theater. The clean room is essential because we wouldn't want anything to be tampered with. 25 wafers are then sent through a journey that takes more than 100 manufacturer steps. These 100 plus steps are carefully constructed by engineers and developers. One of the main keys to making wafers is a light. UV light that transfers the circuit structure depending on the mass of the wafer. This UV light helps shape the wafer. The new transfer structure are now used as a template. The unprotected part of the wafer surface are edged away. The structure of billions of small current switches are generated on each wafer tiny transistors. After the light stage, the newly wafer moves to the next stage. Silicon is a semiconductor, which means that its conductivity can change by a high precision in placement in the so-called dopant atoms. The next step, we apply fire. At the high temperatures, the dopant atoms become flexible and take on a fixed position in atom structure. Copper dominates the next process step. The finest interconnect wires link up to form integrated circuits. We apply water to our wafer after it has been heated. Cleaning the wafer with water is important because it gets rid of dust and other particles. A barrier level is applied to help avoid short circuits and guarantees reliability. The trenches are then filled with copper and is shipped in 2 months. Huge integrated circuits consisting of conductors link up 100 billion transistors in numerous levels. This is one of the many ways to create wafers, which are then used to create microprocessor chips. To get what the Arduino looked like today, it had to go through the same process as the CPUs went through. By knowing what the average CPU goes through to create the Arduino, we can then add different components to our microprocessors like resistors, inductors, or capacitors. This will help with coding and decoding. The Arduino microprocessors numerous things, which all starts with wafers of silicon.
And today I am here to explain what is an Arduino, how to use it, and what are its applications. Arduino is an open source hardware and software platform which can be modified and used in many ways. It is a microcontroller board and is also called a small computer. Microcontroller is a control unit from which electronic components like motors, LEDs, buzzers, and sensors can be controlled or can react or respond with physical world. It works like an interface. Whenever we make an autonomous robot, we pre-program it so it can work with physical world like we want it to work, or respond or react. Now we can say that this works as a brain of the board. Now let's have a close look at Arduino's board, but first of all, I would like to explain why did we specifically choose this software for this project. We use Arduino for this project for a variety of reasons. Some of them are that it is easy to use and easy to understand. Also, it can be easily controlled by a person who has little or no knowledge about computer programming. So keeping our project simple and understandable, we use this software. First of all, we'll look at USB plugin. By using this port, we can connect Arduino with computer so that we can upload our program to Arduino. This port can also be used as a power source if we can connect it with any power belt. Now let's see the DC supply port. It is necessary for us to know that Arduino can safely operate between 7 volts to 12 volts. So we have to connect it between 7 volts to 12 volts to an external source when we will on and use it. So this is a barrier socket which is used to power Arduino. We generally use light volt battery or barrel DC adapter. Now let's look at power pins. So what are power pins? As you can see that the thing we call voltage input, we can also give power to the pin through it. We can also give the power to the Arduino through these voltage input pins, which is generally of 9 volts. 5 volt pin is regulated on it with generally supply of 5 voltage supply. 3.3 volt pin give us 3.3 regulated supply and ground too. Whenever we connect a circuit, we have to connect one of its terminal to ground so that circuit can be completed. To connect it, we will use this pin. Now we have analog pin where we connect analog sensors, and digital pins where we connect our digital components. The both connect input and output in these pins. The integrated circuit chip has a memory of 32 kilobytes. This supplies signals to all pins and controls it through program logic. It is also called control head. Now let's have a look on on-board LEDs. First of all, on and off LEDs. Whenever we power Arduino, that is, whenever we will connect a voltage source, then this LED will glow. This indicates that the board is on active mode. Now let's have a look at TX and RX LED. TX means transmitter, RX means receiver. Whenever we transmit or receive a data from Arduino, then this LED will glow. Pin 13 LED, also known as load LED, convert with the pin 13 in series directly to connect in series. So this is the outlook of the hardware board Arduino. Thank you.